Okay, we're off and running. Okay, good. So Jacqueline's experience, is it Jacqueline or Jackie? I don't think I've ever asked you.
You can call me Jackie.
Okay, Jackie. Okay. So Jackie's experience is informative. So if you don't mind me sharing a little bit, I think, yeah. So anyways, her scores weren't transferring over, but the problem is on my end, it wasn't appearing either. So I think there's sort of a disconnect going on with her account. I can't fully explain it. So, but what she did was take screenshots from her end showing, hey, I've got 100 on this, or whatever mastery level she's achieved, and that was sufficient for me to be able to then go into Hawks and award the credit, and it'll cycle up. So, if that's you're completing something in Hawks, but you're not seeing the score transfer over into the gradebook. That means there's likely a problem. So go into Hawks and take screenshots showing that you've got the mastery. Probably 100 is probably what it will show. Send me those screenshots and I can go in and manually make the adjustments for you. um I
Do you need the ones for today for me?
Yeah, well, when did you do them, yesterday or today?
Today, this morning. So I
Yeah,
can
so
I can send those to you.
yeah, wait till tomorrow. I mean, you can
Okay.
take them, but it'll update at about like 1 a.m. or 2 a.m. Should. So we'll see. We'll see. So anywho, so if that's you, let me know. But that's sort of the way I would encourage you to do. Take screenshots just to, and maybe a good idea just to do, because I think we had sort of an issue at the beginning. One or two students lost some work. So I think, maybe that's a good way to go. When you complete something, just take a screenshot real quick. That way, you have something of it there. Now, in our assignment, I found out why you all couldn't see it. Let me see. I hadn't on my end. Oh, wait, where is it? Did I do it? Yeah. I hadn't on my end published it. So if I go over here, I didn't realize that. So the green check mark wasn't showing up. Now the green check mark is showing up. So what I'm going to do is I'm actually going to edit it and put it to today so that it doesn't show as late on y'all's end. Yeah, okay. So it should now not appear late. It should be visible to you. I think Isis mentioned it was visible to her. Janny, you sent me your note like right when I did it. So
Yeah.
that's why you didn't see it on your end. So sorry for the confusion. So it's one of these things when I mean I've taught math a long time, but I don't create the course stuff. So I'll miss some details every now and then with all that. I've got a new one here for you. Just we're gonna I'll show it here, but it's this one right here that says skill review PEMDAS. We'll do this here as well. And the point is for you to get some examples to see, what it's like to do the order of operations. And these are going to be, not all of them. It's. I'll show it to you. What it looks like. It's this right here. This right here. So, there's I think only like 6 questions. Okay, so order of operations. Testing you on positives and negatives. The left right rule for for multiplication and division, the left right rule for addition, subtraction, exponents. I got some absolute value in there and some exponents. Now A is a good test question, by the way. This one here on the fourth slide. Uh, that's a good test question because it I can see it captures a lot of things. Parentheses, absolute values, exponents, signs, a whole menagerie of stuff. So with one question, I can basically tick off like 3 things. So that's a good test question. Then there's some evaluation. It's more of the same really, and then combining like terms and distributed property. Now we'll do some of this here. So this is not something that you're gonna all of a sudden do on your own. I'm not gonna leave you to it and with such a quick turnaround. But anyway, I wanted to mention that as well. It's downloadable there. And again, it's designed for you to get 100%. So if you don't get something right, you resubmit, you get it right, things like that. But that's why we do it here is to help you out with that. Um, Let me go back to the class and let me kind of check in. I haven't checked on progress in terms of where everybody's at with the assignments. in terms of what was due yesterday, but just a kind of a quick reminder where we at. This was the this was
Not to interrupt, Professor, Tiffany said that she's having issues with her son. She won't be here today, and Addie's trying to get in.
okay. Trying. I wonder why she's not.
That happened to me earlier in my class. It took me 15 minutes and then it finally let me in.
Hey, I just made
Okay, good, good, good. Okay, yeah. So just a kind of a quick reminder. I haven't checked everybody's progress, but the due date here for this stuff has come. So if you're not there, I would encourage you to spend some time tonight and tomorrow to get it to update it. And then because we will be doing this test on Wednesday, and you'll see it. I haven't fully updated it yet, but you're going to see the test in there and do things, and you'll do it there. But anywho, get up to speed because you don't want to. Basically, it's on the test. You want to be ready for when the test comes. So let me pause. Are there any questions? I mean,
I do have a question.
yeah, go for it.
Okay, so in the group me yesterday, there was a lot of people like questioning about possibly having you go over some things, and that's where I've been stuck. Like for the last 3 days, 1.6 and 1.7,
Hmm.
those two. I don't know. I feel like I watched the video over and over. I went over our notes, and I just feel like whenever I started doing the practice and stuff, it was like it's like it just didn't even like seem like it was part of the lesson. I don't know if I was just confusing things or
Oh, let me see.
and I'm looking right now. I did get my certification for 1.6,
Okay.
but it's not showing up there.
Yeah,
It's showing 0.
yeah. Take a screenshot and
I did take a picture, but it was yesterday afternoon, so I don't know. Maybe it just hasn't been 24 hours.
maybe maybe I don't know on that.
Mhm.
I can
So
fix it.
we're gonna do this screenshot system until we get it right.
Okay.
I mean, is there a problem in particular from 1.6 that
I did have one, and I still I just put a question mark by it. Let's see. Um, I think it is. Let me see if this is it.
It should let me take my test if I go through the Hawks one, right? Even though you're putting it through yours, it's also going to be in Hawks, right? So
it's
I
going to
should
be in
be able
Hawks? Yeah, you won't
to.
see it.
Okay.
You won't. You're not going to see it yet.
Mhm.
I'll
No,
do
no.
it
I'm
tonight.
saying
You should see it tomorrow.
because I'm going through the other portion of it and it's giving me the problems going back and forth. I just want to make sure it wasn't like just on your side, like on Canva side kind of, and then I
Should not
wouldn't be
be.
able to enter it.
Should not be.
So,
Well, I'll make it tonight so that tomorrow you can go in and say, "Hey, I see it there." You know, something like
okay. That makes me feel better. Thank you.
that. Mhm.
Um, okay, this is just one of them. I just had a question because it was 6x plus 24 equals 2x minus 3. And I just kept doing it over and over. I could not figure out how they turned the second step into a negative 2x. Um,
So wait, before, what's your goal? Always keep in mind this is a puzzle.
oh, I didn't. Let
What
me
do you
see if I
want to?
took a picture. Maybe I
What's
took a
your
picture.
goal?
This was solve the inequality with one variable and simplify it, I believe. Let me see if I have a picture. Uh,
So it had an inequality, not an equal sign.
hold on. I'm sorry. It was an equal sign.
Okay. Yeah, it's
Uh,
the same. It doesn't matter. It's
yeah.
so
Um,
it's something like this. Software X.
but trying
So
to see so many screenshots.
when it says solve, what do you want your answer to look like?
You want X on the left and the answer on the right of the equal sign.
Right. Perfect. I love it. So then when we inspect this equation, what's preventing you from, what do you need? Either A, what's preventing you from doing that, from achieving your goal of X to the left and numbers to the right? Or another way of saying it is just saying, hey, how are we going to achieve that goal?
Well, the 2x needs to be on the left and
Oh,
the
let's
24
stop
needs to be
there.
on the right.
Let's stop there. I like that. You spotted the 2x. You know what side it needs to get on. The question now for you is how are you going to achieve that? How are you going to get the 2x to the left side?
Well, you have to divide
So
because,
this is what you want to write down. When you want to move a term from one
okay,
side to the other, that's add the opposite. So what is 2x right now? Is it positive or negative?
positive.
So the opposite is,
Okay, so that's where I was confused because I was trying to understand how they got negative, but because it's positive, I have to send it to the other side negative. I mean, yes, I have to turn it negative.
right.
Okay, because I was confused, I guess, because I saw the -3. I was thinking, okay, so then it needs to be added over here, not subtract, but it's not in front of the 2. Okay,
Right.
that's my issue right there. And there was another one, and like I said, I, I think from what I read, other unless they figured it out, other people were having issues with those 2 lessons also. Um, let me see. I don't want to hold you up. I'm just looking if you want. Oh, okay. This one was all right. It was V2 equals V and then a little tiny O at the bottom of the V and then up to the second power plus 2AX.
Yeah, that one was crazy.
And I still like, I'm like,
Say it again.
it's V is in Victor to the second power equals V and then there's a little small O at the bottom of the V and then to the second power. Plus 2AX.
So what do you have to do?
Um, let me see.
Software X?
Yes, software
Okay.
X.
So you treat this as the variable.
Okay,
So what's the goal? You want
put
to
it to
get
the left.
X on one side and everything else to the other side.
Okay.
Okay. So how did we do that over here?
We
You move terms
moved.
from one side to the other. So you can move that term right here from one side to the other.
What exactly does that mean? Like at the bottom, with the little small O at the bottom, or is
It's
that just?
we say V naught.
Oh,
0 O, like the knots, the naught 2000s, knots, zeros, just
okay.
zero. That's all it means.
Oh,
But
okay.
the only difference is you're Jana, I'm Andrew. That's just the name of a variable.
Okay.
It means nothing. Let's say it that way, other than to say that V is different from the other V. That's really the only thing. They're not like terms.
Okay.
But the exercise is the same as if you were over here. You got to move this thing right here is stopping you from getting that x by itself. So it's adding, so you got to subtract it from both sides to get rid of it.
Okay.
So you just essentially add the opposite. Now over here, they're not like terms, so you can't combine them. That's the significance of that zero down at the bottom. So it's v minus or v squared minus v naught squared, and then 2ax. Now keep in mind the x is our variable of interest.
hmm
So now what do we have to get rid of?
The 2A
The 2a. How are we going to do that? What's the opposite operation?
divide
By what?
2A.
Exactly. Oops. And then you can just go ahead and divide everything over here by 2a, or individually if you wanted. But basically, this becomes the answer.
Okay.
I got that question wrong so many times because I couldn't find that little zero. I didn't know it was in the little input box thing.
Oh, that's a toughie. I don't like that one.
I don't either.
Yeah, I was like, losing my mind on that one.
Yeah. And the only other question I have, I had submitted all of my answers for the first skill review through email. Do you want me to go back and put them all in the blanks for the other ones? So it'll be
Yeah,
easier for you to grade.
yeah. If you would go ahead and put it in the for everybody who sent me an email about that. My apologies. I just didn't see it wasn't the box wasn't checked. So go ahead and submit copy. If you emailed it, copy and paste it and throw it right in there. Put it in a Word document. Submit that in there so that I have an official record. So, basically it's for accreditation. If you're getting 100, there's got to be a reason why you're getting 100, and that piece of paper really it does it for us. Yeah, go for it, Adam. Question.
Just a quick one. When to flip? It's just been a couple days, but when to flip the sign when it's negative?
When do we do that?
When it right before the answer. I don't.
You have a specific question in mind? Because the thing is, you're talking about the sign. What do you mean by sign? Do you mean the positive, negative, or do you mean
No,
the
I
inequality?
meant. I'm sorry. I meant the
The
greater than,
inequality.
less than.
Yeah, the inequality.
Inequality. Yes.
So what's the guide that I gave you? I mean, there's the rule when you multiply or divide by negative, that's when you change the direction of the inequality. But when in the process does that happen?
Uh, that's what I'm trying to get.
Well, let's take this one right here. Okay, so I'll just change it to less than. Still the same thing. So the next step here is what? Subtract 24. Subtract 24. That's an interesting one. So it's 4x is less than -3. Now, notice in these first two steps, we subtracted. Does the rule apply? Do you switch the inequality when you subtract?
No.
No, so leave it alone. Where's our first opportunity for some multiplication or division?
When you divide the 4.
Very last step. So do I flip the inequality?
No, because it's a positive 4.
Right. So that's one of those practical rules of saying, yeah, the rule is when you multiply or divide by a negative, turn the inequality around. Practically speaking, what that means is it's the very last step. That's when the rule comes into play.
Okay. Okay.
Anything else right quick? Not your last chance.
Yeah.
Okay, go for it, Addie. What you got?
All right. Okay, so we have -1/9.
Pardon me, I'm trying to.
No worries. And in parentheses, y minus 6. And close parentheses. Equals 1/6. And in parentheses, y plus 4/5.
I'm not going to do that to you on a test, by the way.
Great. Yeah, I dedicated a whole page and a half to that one problem. And
Okay.
wasn't sure if I got it right and I got it wrong. It's just it's a lot of steps, and if you get one wrong, then you're screwed.
So the way I would approach this one is if you just keep in mind the number on the outside of a parentheses is multiplying the stuff on the inside. Okay, so that's sort of the operation here. Now, we don't have to get rid of the parentheses first because the numbers in front here are fractions.
Right.
We can get rid of the fraction first. Okay.
Okay.
You can get rid of the fraction first, and a lot of times it's advantageous to do that. So the way that we would do that in this case is you ask yourself, Well, what's the common denominator between the 9 and the 6? What's the first number that both 9 and 6 go into?
So whenever I looked at the tutor, it said 90. So it says multiply everything by 90. And I think it threw
You,
me for a loop
you can
because
do
I'm like,
90,
where is that?
but why are they doing 90? That's the
I
least
don't
common denominator between
know.
9, 5, and
See.
6.
Yeah, but it's like there's so many ways to do each problem, and I'm just so I wish like there was like one way. But yeah,
I mean,
so eight.
there is a master way. I mean, that's not wrong to do it, to do it
Yeah.
that way. Um, I just sometimes I look at things piecemeal. I kind of
Okay.
I don't always look at the bigger problem. I look
Okay.
at one part of it and
All right.
resolve one part of it at a time. And for me,
Yeah.
when I go ahead. So I can get rid of the 9 and the 6 easily because
Okay.
they're just out there on their own. See that 4/5, the reason why I'm not looking at it is because
Yes.
it's
In the
inside
print.
parentheses.
Okay. Got you.
So that's why I'm kind of putting blinders on and saying just not really worrying about it because it's there. I can deal with it later, but I'm not ready to attack inside the parentheses yet.
Right.
So I say let's do 18.
Yeah, I like that better. I didn't think
Okay.
about getting rid of the things outside parentheses first.
So when I do
Like,
that, then the 9 and the 18 here cancel to leave a 2, so that becomes -2. 2 times -1. So the stuff on the inside doesn't change because this stuff here is multiplying. Okay, that's separate and apart. And then over here, the 18 times 6 leaves us a 3. 4/5. Now I am eventually going to have to deal with the 4/5, just not yet. Okay. So now I do the multiplication, and I'm gonna well, so when I do that, well, now I do the distributive property. So take the -2 inside, so it becomes -2y plus 12. Then 3 times y is 3y. Now 3 times 4/5. Okay, that's not pretty, but we can do our multiplication of fractions and it becomes 12/5. Now I can deal with the 5. Now I can deal with it because it's outside of the parentheses. And I could do
okay.
that. I could do that just by multiplying everything by 5. Everything. You have to multiply
Right.
this 5.
Yeah.
And so I'm going to type now because it's a little easier. So that becomes -10y plus 60. I forgot the 5 on the other side because 15y plus 12.
Okay.
So you can piecemeal it. You don't have to do all at once. And then I'll finish it, by the way. This becomes -25y equals -48.
Okay. And I apologize, Mr. Albertson. So why did we multiply both sides by 5 again? Okay, so you have the denominator of 5 on the right side of the equal sign. But how do I know? How do I know when to do that? I don't know, I guess.
Well, the fraction's a giveaway. When you have a
Okay.
fraction, you can multiply by whatever's in that denominator. But you're guaranteed
Okay.
to cancel. You're guaranteed to cancel that fraction with that denominator by multiplying by that denominator. It is guaranteed.
All right.
So because the fraction finally broke out of the parentheses, I was able to deal with it at that point.
All right.
It's not going to get that complex on the test. I don't do that.
Sounds good. Thank you.
Yeah.
But
Did you get?
yeah.
Are you done with that particular assignment?
No, sir.
Okay. So when you're dealing with fractions, just do know you don't have to find a magic number that will get rid of every single fraction. You can say, well, you know what? I I can deal with that one and multiply everything. Now you do have to multiply everything. So that's the thing though. Um, and on this note, by the way, I don't want you all to spin your wheels. Um, try, Send me your work. Take a picture of your work and send it to me because oftentimes I can just see you're missing your 5 right here. You're missing this. Or here's where the 90 comes from if you want. So
Right.
you don't have to. I mean, do the best you can is what I'm saying. But if you're spinning your wheels, just throw me a note. And
Thank
it'll be
you.
good. Yeah.
Awesome. I appreciate that. Yeah, I think that's just the tricky part about doing online is that like can't see the work and but yeah, I appreciate that. Thank you.
Okay. And I do want to remind everyone. Let me go over here. Just remember, there's Khan Academy. There's more videos. There's other helpful things to help you out. I mean, I just typed in solve linear equations, but if you go to 8th grade math, typically where you're going to be, and then you have solve equations with one unknown, which means one variable, and you can just scroll down, and I think there's a fraction element.
Okay. Okay.
Yeah, there's one. Equations with variables on both sides of the fraction. Forgot there's a few fractions one. So you click it. It's a video. So then using this one, the distributor property, but you can see the question actually. I'm going to mute this. But if we go for it, it's kind of a little similar to what we had. Not really. Let's see. Oh, variable. We're not doing that yet, but that's coming. So I encourage you to just keep. I mean, Hawks is good too. It's got some good stuff, but sometimes different things help out. So you just never
Right.
know.
I do have one more question.
Uh-huh.
Just like you said, we could go to Khan Academy. Is there a site we can go to? Like, we had 2 different problems that had to do with distance and speed and mileage. And I kept trying to figure it out, and then I realized that we had done the one with the angle. They had a
Mhm.
formula. Is there like where we can go and just like maybe make a card with all the different angles for if one of those were to come up on the test?
If you want to make a card, yeah, you can make a card.
Is there a certain site like we can go and pull them up and like write down all the different formulas that we wouldn't know unless we
Let's say it this way. If I'm going to give you a word problem with the geometry formula, I'm going to give you the formula.
okay.
Yeah,
Perfect.
so we're not in a geometry class. I'm not asking you to memorize all this stuff.
Okay.
No, you see, yeah. Okay, I see what you're saying. Okay. Well, let's move forward a little bit here, and we'll pick up the skill review on some of these things in just a little bit. But let's finish up. Where were we finishing up, by the way? We were looking at the rules of exponents. Remember, we talked about the product rule, we talked about the quotient rule, and we talked about, did we talk about the negative exponent rule? Where it's the shift up, shift down? I think so. So, Nards.
The last rule we went over was the power rule.
We did do the power rule.
We
Let me
began to.
did we do something like this? Where there's a negative exponent?
We did do negative, but we didn't. Yeah, we did like 3 or 4 problems, and then class ended.
So remember, this one shifts down. Just the x part. Oops. So it becomes 2, and then everything else remains the same, but the x squared shifts across the fraction bar and turns the exponent positive. So we did the power rule too. Okay, so then we've probably done most everything here. So the one rule I didn't go over, and just to kind of help you out, is the zero exponent rule. The zero exponent rule. This one basically just says when you have x to the 0, that thing means 1. There means that remember what the exponent tells you. It tells you how many of the bases are there, okay? So x squared means there are 2 x's because the exponent's 2. X to the 45th power means that there are 45 x's because the exponent is 45. Tells you how many of the base how many copies do we have. When the exponent is 0, that is telling you there are no x's. None. 0 x's. Well, there has to be something there. You can't just eliminate it. So there's always, remember, why is it a 1? It's because there's always a 1 in front. So this is saying there are no x's, but the 1 in front stays behind as a placeholder. Okay? So that's where the 1 actually comes from, is it's always there in front, implied to everything in mathematics. So when we do something like this, how could we do it? X to the 6th times x to the 0. There's a couple different ways to approach it. And that's the drawback to rules of exponents is, Addie could do one way, Janet could do another, and Adam could do another one. So, not that's true for every problem, but there are multiple paths. But the point is you can end up in the same place. But ultimately, it's just, if you see something that applies, apply it. Do it one rule at a time. So how could we do x to the 6 times x to the 0? Well, we could apply our rule here, okay, and just replace that x to the 0 with what?
A 1.
A 1. So this becomes x to the 6th times, and replace it with a 1. And 1 times anything is what?
The same.
The same thing. So x to the 6th. What's an alternative way I could do this particular problem?
Times the, I don't know, exponents.
The times of the exponents is
But adding them.
Add the
Yeah.
exponents together.
right. Say, who said the other one? Right. So I have the same base multiplying together, so I add the exponents. That's the product rule. So I add the 6 and the 0, and lo and behold, look at that. It's the same exact thing. Notice we got to, sorry, wrong. Notice we got to the same answer using 2 different rules, 2 different properties, and they're both equally valid. So it's not always the same. It's not always that everybody has to do the same thing. The rules of exponents are pretty flexible, and there's a reason for it. I'm not going to get you confused about it, but the point is if you see a property that applies, go ahead and apply it. It's not one thing only. Okay, so be prepared for that, this sort of thing. So here's another one we talked about. So what's the rule that applies here?
Adding the exponents.
Right, the product rule, you're multiplying the same base, add the exponents. Perfect. Can we apply the 0 exponent to a regular number? Excuse me?
Yes, there's 0, 3, so there's a 1.
Right. The rule applies. The 0 property, all these rules about the rules of exponents, they all apply regardless of whether you're dealing with if your base is a variable or if your base is a regular number. The rules still apply. Why? It's because, keep in mind, variables are numbers too. They're just numbers we don't know.
If there's 0, 3s, why does this exist?
There's a larger purpose. So you're not privy to it when you get to like algebra 2, if you will, and then you get to calculus and higher. We write these things as like what we call series expansions. We look for patterns. And so we can actually write this expression as a longer expression, and it's got some utility. The notions of pi, there's a whole like thing about it. So it does serve a larger purpose in algebra, but here for you all, it's not so relevant.
I regretted it instantly.
Yeah. So sometimes it's less is more. I don't want to cloud you with too much junk. Okay, so this is something else we also did. Remember, we're multiplying stuff here. Um, you treat the numbers, the 2 and the 4, multiply them like you normally would, and you do the um, product rule on those. So this is stuff we talked about a couple days ago, I think last Wednesday. Similar here. Remember, this is the quotient rule now. You have divisions. How do I know it's the quotient rule? Because you got a fraction bar right there. A fraction bar. So what's the rule with the quotient rule? What's when you have the same base on different sides of the fraction bar, you what the exponents?
Flip it.
Say it again.
Flip it from positive to negative or vice versa. Negative to positive.
You could. There's nothing
Oh,
wrong with that.
oops. I'm not sure what rule I'm thinking about then.
No, that's fine. So look here. Can I go ahead and apply my product rule there?
Yeah, you can.
So for this one, I like to do the negative exponent rule last, because sometimes you're going to find that the rule that you don't need it at the end of the day. It just makes it more complicated. You give yourself extra work. So my recommendation is check to see if you can apply the product rule or quotient rule first. So check if you can apply the product rule first, then check if you can apply the quotient rule after that. Okay, so here we can apply the product rule first. How do we do that? Well, we multiply 24 times 7. Calculate time. I have no idea what that is. So 168, 24 times 7. Then x to the 9th and x squared. We apply the product rule that says when you're multiplying the same base, you add the exponents. So that becomes 9 plus negative 2. And we just bring over the 14yx. Whoops. Just nothing changes on that one yet. To the 7. Okay. So now come over here. Simplify this. 168 x to the what? 7 power over 14y x to the 7th. Okay, now what?
168 divided by 14.
Yeah, so what's 168 divided by 14? Is it a
12.
nice, neat number? It is. So remember, you do your division of your numbers like you normally do. So this becomes 12. What happens to the x to the 7th?
Cancel.
Cancel.
Addie, can you mute real quick?
Yeah.
It's echoing.
Oh, I think you got an echo. So the x to the 7th cancel. Do y'all see that? Do y'all see why the x to the 7th cancel? Let me come over here. Suppose I have the fraction 3 over 3. What does that reduce down to? 3 over 3.
1.
1. They cancel. What's the rule you're relying on there? Same thing in the top and bottom. They go away. So that's why here the x to the 7th cancel is because they're the same thing in the top and bottom. It's the same rule. You didn't realize it, but you've been doing the zero property for a long, long time. We just called it something different back then. It is the zero property, by the way. Because let me sidebar it. Let me do a sidebar. X to the 7, you do the quotient rule, becomes 7 minus 7, which becomes x to the 0, which becomes 1. That's the zero property is how that rule comes about. Same thing over the top and bottom, cancels to give a 1. Really what you're doing is you're applying the zero property, zero exponent property, without even realizing it, I think. So the x's go away, those cancel. What about the y?
Bring it down.
Just leave it in the denominator. That's the answer. So as sort of a checklist, see if you can apply your product rule first, see if you can apply your quotient rule next, see if you can apply your power rule, and at the very end, now you're looking for the negative exponent rule. That's sort of if you want some sort of process. Okay. So I think we've done actually pretty much, I can see we've probably done a lot of almost everything here. We've done that one. We have done that one, by the way. By the way, just this one, the exponent here is 1. So use your, you can use your negative exponent rule. You can use your quotient rule too. But just know that the rules apply to the numbers as well. This is actually not as terrible as I thought it was going to be, because they can really get some gnarly problems as well. Oh, look at that. Okay. Okay, so I'm going to then, so we've done we've done this one. Good. I've actually probably, we actually probably did more when I was in my discussion than you're actually going to need to do in that. The reason why we spend so much time talking about the rules of exponents is because it's really going to help you with the factoring. That's the next one after this, and that's where we're going to start looking at section 1.3. So go ahead and draw a line in your notes because it's much different. So I'll actually use this as my whiteboard, if you will, because I can probably work with it a little easier. So the whole point, when you do your rules of exponents, keep in mind the purpose behind it is to bring things together. Okay, to bring things together. You know, you have x's in multiple spots, you have y's in multiple spots, and you're trying to bring them together. It's not really combining like terms, but it's combining like variables to the extent that you can when you're multiplying. That's what the rules of exponents are for. Now we use that because what we want to do is we want to do some factoring. Factoring is a way to break things apart, okay? But the process to break things apart relies upon our rules of exponents. So it's sort of an interesting feature for all this. Hold on just a minute. Okay, good. Okay, so before we get into factoring, polynomials at least, let's actually talk about what does factoring mean? So let me ask you a number. What numbers multiply to give me 12? And you would say, what?
2 and 6.
2 and 6, perfect. Anything
4 and
else?
3.
Say it again.
4 and 3.
4 and 3. So I'm going to say 3 times 4.
1 and 12.
1 and 12. Any other numbers? Negative 1 times what?
Oh,
Negative 12.
Negative 12. Remember, 2 negatives give you a positive. And so then all you do is you just change the sign. Same numbers, just give me the other sign. I want you to need to start thinking of that too. Always keep your negatives in mind. That's the lesson. But my point right here on the first level is, this is what factoring is. Give me 2 numbers that multiply to give me the original number. So what are 2 numbers that multiply to give me 12? And that's the exercise that we just went through. Now we can take that concept and we can apply it with polynomials as well. But before we do that, I don't want to do that just yet. The next thing I want to do is then move on, and let's take a look at 2 numbers. You know, let's take 12, and then let's take, I don't know, 18. Okay, and I want to know what is the GCF between them. Let me do this. Let's bring this over here. Spread it out so much. Okay. My pen doesn't want to. I got some terrible handwriting. Apologize. There we go, 18. Okay, so what I want to know is what is the GCF between them? Now, what is the GCF before we get too far along?
Greatest.
Common multiple factor.
Factor, right. So how would we do that as a definition? It's the largest number that goes into the original numbers. There are a couple different ways of doing it. Okay, so I'm going to show you one way, and I'm going to show you another way. Okay, so one way, when the numbers are small, like 12 and 18, this is probably the easier way to do it, is I just list out the factors. We already listed out the factors of 12, 1 times 12, 2 times 6, and then 3 times 4. And when you think of GCF, go ahead and stick with the positives. I'll tell you when the negatives come back into play. Let's do the same thing with 18. What are the pairs of factors? And I want you to also think about these numbers as pairs of factors. There's a number times a number, okay? So this is a pair, 2 values. 2 times 9, and then 3 times 6. So what the greatest common factor asks is says, okay, well, find the factors that are common to both. What does that mean? Find the factors that appear in both lists. So a 1 appears in both lists. A 2 appears in both lists. A 3 appears in both lists. And then a 6 appears in both lists. So of those common values, which one's the greatest?
6.
6. That's exactly right. So that's one process. List out the pairs of factors for each and see which number is the highest one that appears in both lists. That's one way to do it. And that, I find, is the easier, more direct way when the numbers are small. Small, something less than 100, okay? Kind of depends on what your definition of small is, but this is a surefire way to do it, is to sort of find that. When they start to get larger and maybe not so intuitive to work with, there is another method as well, and it's called prime factorization. Prime factorization. So I'm gonna take this off the screen. We're gonna keep with this one, but we're gonna do this in terms of prime factorization. So can't really. So prime. I'm not going to be able to type it very well, so I'm not going to do it. Okay, so I'll type this. What I'm saying is a prime factorization. So if you need to Google it or something. So this is basically, you write the number as a product of primes, prime values. Okay, product of primes. What do we mean by prime? I think we've talked about this before. Is a prime number is a number whose only factors are 1 in itself. So 2. 2 times 1 is the only way you can factor 2. 3. 3 times 1 is the only way you can factor 3. So 1, 3. So think of prime numbers 2, 3, 5, 7, 11, 13, 17, 19. That's pretty much all the prime numbers you'll need. I mean, you're not going to get too much higher than that. You might get 23 and 29. Okay, that's about as high as you're going to need. So we're looking for basically an orientation to multiply numbers using a string of prime numbers. So we can do it in this prime factorization sort of a couple different ways. Let's take our value 12. There's a way you can draw it as a tree diagram. I don't always like the tree, but the tree's effective. And basically you say, well, what numbers am I going to split the 12 into 2? And so you ask yourself, and what I do is I just go down the list. I always start off with, can I write 12 as 2 times something? Why do I pick 2? I'm just starting at the lowest prime number and seeing if it goes in. If it doesn't, I move on to the next one. because working with small values, I like. I don't like working with big values, 29s and 19s. It's unwieldy. But I can work with small ones, 2, 3, 5. I like those. So does the value 2 go into 12? The answer is yes. We multiply it as 2 times 6. Now we focus on the 6, and we ask ourselves, is it a prime number? Is 6 a prime number?
No.
No, it's not in my list. That's why I wrote my list down, so I can see what my prime numbers are. It's not on my list. So no, it's not a prime number, so it was what we call a composite number, meaning there are 2 primes that will go into it. So how would I factor the 6?
2 times 3.
2 times 3, yeah. So stick with the 2. Stick with the 2 until you can't do it anymore. Okay? So break this one up into 2 times 3, okay? And so when you write so now notice at the end of every chain is a prime number, 2, 2, and 3. And so once you reach that point where every limb of your tree ends in a prime number, that's when you're done, and you just write it using the ends of the chains. So 2 times 2 times 3. And if you did that multiplication in your calculator, you would get the value of 12. So let's do the same thing with 18. I factor that into what?
2 times 9.
2 times 9. Then what?
And then you have to
3 times 3.
For the 9, right. So factor the 9 into 3 times 3. Is my chain done?
Yes.
So then I write it as a factors of product of primes. So multiplying the 2 times 3 times 3. Okay. So now I can build the GCF using this. What you do is you look for what are the factors that are in common. And so we have, which factors are in common? I have 1, 2 that is common to both, and I have 1, 3 that is common to both. So I multiplied those, just 1, 2, and 1, 3, because that's all they had in common. Do that multiplication, and look at that. It gives me my GCF of 6. So this is a completely different way to find the GCF, and this way is nice when you have larger numbers that you're dealing with. So I can show you an example of that. But let me pause here. Any questions on this? So remember, you're trying to keep your if you need, just keep a little list, a little post-it note. Just write down prime numbers 2, 3, 5, 7. These are pretty much all the prime numbers you'll need. You shouldn't need. I would bet you won't need any higher than 29. Anywho, so let's do another one, but more complex with higher numbers. Okay, so let's do the GC. What's the GCF? So we want to find. Oops. Do it up here. I want to do the GCF between what and what. Anybody want to give me a number? Let's see. 86. That's funny. Okay, 86 and what? Sure, 98. That's good for me too. Okay. So we're going to do prime factorization on this one because candidly, I don't know what goes into 86 and I don't know what goes into 98. I just can't think of those numbers. So I draw a total blank. I'm like, okay, prime numbers it is. So what am I going to break 86 into? What's my first chain? Can I change this? I don't want to do 86. Can I do 84?
Because that number was crazy. How do you do that?
It actually reached a prime number very quick, quicker than what I wanted. I'm going to change it to 84 right quick. Sorry. So When you're asking yourself what prime numbers go into it, use your knowledge about numbers. I know the value 2 goes into 84. How do I know that? Does anybody, what would you say?
Because it's even.
Because it's even. Every even number, 2 goes into every even number, for sure. Always. Doesn't matter what the number is. So I know I can break this up into 2 times something. 2 times what? I'll break out my calculator. 84 divided by 2 is 42. Now, 42, still even. I'm going to keep with that 2 until I cannot use the 2 anymore. So I'm going to break it up. 2 times what?
21.
21. So now it's the 21. That's what I'm focusing on. Can I use the 2 there?
No.
No. Because why? Because it's odd. 2 cannot go into odd numbers. So I need a new prime number. And so you just move up. Can 3, that's my next prime number up. Can 3 go into it? Yeah. 3 times 7. And fortunately, it ends because 7 is also a prime number. So 84 would be written as 2 times 2 times 3 times 7. So let me pause there. Questions on this one? Now, what about 98? I'm going to kind of move over a little bit here. Well, it's even. 2 times what?
49.
49. Okay, hit an odd number real quick. So I can't do 2 anymore. Can I do 3? Now pretend you don't know what the answer is, by the way. But how would I do this? Can 3 go into 49? Well, I don't know. 49 divided by 3. No, it's a decimal number, so 3 cannot go into it. Can 5 go into 49? So I'm just working my way up the chain. 2 won't go, 3 won't go, 5. Will 5 go?
7 will.
Yeah, you know.
No.
How do we know? What's the rule for 5s? If it ends in a 0 or a 5, 5 can go into it. This is just those patterns of numbers that you kind of built up over time are coming into play a little bit. Now we know this one. We know it's going to be 7, so I'm not going to play around anymore with it. But that's what that one becomes. So my point is, though, if you were at a number where you didn't know, use your rules, your properties, your patterns of numbers. If it's even, 2 goes into it. If it ends in a 0, 10 goes into it. If it ends in a 5, 5 goes into it. So it's those sort of rules, okay? But you can always just ask yourself, well, does 3 go? Does 5 go? You know, things like that. So this one here, 98 becomes 2 times 2 times 2 times 7 times 7. So how are we going to build the GCF then? Well, you find what's common. So what's common?
2. 1. Just 1, 2.
1, 2, and what?
1, 7.
And 1, 7. That's it. So the GCF just happens to be a lowly 14. Now, I would have never guessed that on my own. I would have had to have done that. I'm just not good with numbers like that.
Is there a way to verify that? But I mean, can you just do 84 divided by 14 and it should be an even number?
It may or may not be an even number, but
I mean, not even, a whole number.
it should be a whole number, right? So that Adam makes a great point. You can check this. Take the 84 and the 98 and divide them by 14. You should not get a decimal. You should get a whole number. Excuse me. That's exactly right. Okay. So let me pause there. Any questions on finding the GCF of 2 numbers? Sort of fun, you know, as far as I'm concerned. It's not terrible. Oh, let's see. Okay, so it's a mantra. You're going to tell yourself letters are numbers too. And so let me write something up here. What's the GCF? Oops. What's the GCF between x to the 3rd and x to the 5th? I like that. Well, how did we go about doing it with regular numbers? We broke it up into something times something, okay? Well, we can do that here too, can't we? X to the third is what? X times X times X. And what's X to the fifth? X times X times X times X times X. 5 X's, okay? So bear with me. It's gonna take a little. But remember that from exponents? It just tells you how many copies do you have of the base. So x to the third, 3 x's, x to the fifth, 5 x's. Ask ourselves the question, what do they have in common?
They're both X's.
How many x's? I got 1x, I've got 2x, and I've got 3x. So they've got 3 x's. Do y'all see that?
Mm-hmm.
And so how can we write x times x times x?
X to the third.
X to the third. And look at that. It was one of the original values. So variables are easier than numbers because what's the rule? You find what variables they have in common and choose the smaller exponent. Find what variables they have in common and choose. So the GCF of variables is to find the variables that are in common and choose the smaller exponent over those common variables. Find the variables that are in common and choose the smaller of the exponents. So with that in mind, let's play around with it. Okay, there we go. So let's do x to the 7th, y to the 4th, and then come over here, x to the 3rd, and then y squared. What's the GCF?
X to the third y squared.
Yeah, what do they have in common? Oh, I didn't mean to do that. Let me change this up. I meant to do this. Not y to the squared, y to the 5th. So what do they have in common? Well, there's an x and a y that appears in both. It's got to appear in both. Then you look at the x's. What's the, so look at the exponents, a 7 and a 3. You choose the smaller. Write that a little easier. And then you look at the y's. It's a 4 and a 5. Choose the smaller. Oh, did it again. Not 5, 4. Okay. Voila. That's it. Just find what variables they have in common and choose the smaller of those variables. And notice we picked one from over here and we picked the other one from over here. So it can come from 2 different places as well. So let me pause here. Questions? So when you're finding the GCF of numbers, you're looking for the largest number that goes into both. You can do prime factorization to help you out. When you're doing GCF of variables, you see what variables appear in both, and you choose the smaller exponent of those common variables. Yeah, Adam, is that your hand raised?
Yeah, so just a quick question. So if there's like a gotcha question and it's like the numbers, I don't know, 98 and 23, is it no solution?
Where's the 98 and the 23?
Just if it gave you 2 numbers and you got to find the GCF, one
So
of
you're
them's
saying
prime.
you're saying plain, yeah, just not in an exponent. So,
Right, yeah, plain, sorry.
So 98 and 23. Yeah, look for the prime factorization. What was this one again?
Oh, jeez.
2 times 49. It was 2 times 7 times 7.
2
Yeah,
times 7 times 7. So then what's this one?
23 times
Well,
1.
no.
1
1
times
times 23.
Uh,
Keep in mind, there's a 1 times in front there. So what's the GCF?
1.
1.
oh,
It is a gotcha, but it's relying on the fact that 1 is always there.
cool.
So let's put this together then. Suppose I have a number 8x to the 8y to the third, and then 10x y to the fifth. What's the GCF? Well, how is this different? There's numbers in front, okay? So all this does is just putting two things together. You find the GCF of the numbers in front, 8 and 10. What's the GCF between 8 and 10? What's the highest number that goes into both?
2.
Perfect. 2. Then you move to the variables. What variables do they have in common?
X
X. Anything else?
and Y.
And Y. Now look at the exponents. Okay, so we're at the X. So we look at the X to the 8th and then the plain X. What's the lower exponent?
Just none. Just it'd be 1.
1. Perfect. See? You're remembering the rule. I was testing you with uh, a trick question, but I was quizzing you. Did you remember it?
Yes.
The 1. And that because of the 1, that's what that is right there. Just a plain X is X to the first. So it's the 1. So it's a plain X. So we can leave it as just a plain X. And how about the Y?
3.
3. Right. And there it is. So we mashed it all up. We found the GCF of the numbers in front. You find the GCF of the variables attached and mash it all up together. How about that? Any questions?
Now, if we had something like this, would we put the 1 uh, on Hawks, or we just leave it with just an X?
Just an X.
Okay.
Yes. Good question. Now, I'm not going to do it here because we're kind of running short on time. But suppose I had put a Z to the fourth over here. Would that change the GCF?
No, you drop it, right?
No, it wouldn't change the GCF. Why do I not put a Z here in the GCF?
Because it's not on the other side.
Right, it's not common. It's not common, right. There is no Z over here. So it's just more of a refresher or reminder that when we're talking about the GCF, it's got to appear in both. The Z does not. So they're not in the party. They don't they're not on the list. So just a quick reminder on that. Okay, let me pause here. Questions on the GCF? Because this is where we're going now. Because we use the GCF. So now you know everything you need to do factoring. How do you find the GCF? And now take your rules of exponents and we're going to mash them together and learn how to do a new problem. And let me give you a sort of a general thing about mathematics. That is actually how mathematics is done. Take two things I know how to do and let's put them together and see what new problems I can solve with it. So anywho, so let's do something like this. Where are we at? Let's factor. So I want to factor something like this. Where am I at? Oh, 2x to the third plus, got a fly in here, 8x to the 5th. I'm going to come over here and write the steps. The steps for GCF factoring. 1. Find the GCF. Just that easy. 2. Write the GCF on the outside of a set of empty parentheses. 3. Divide each term by the GCF. And then 4. Write the quotients. Remember what quotients are. It's the result of division into the empty set of parentheses. So, and by the way, I'm recording this session, so if you don't get the note, it is there. So what's the GCF of this? If I'm looking at if I'm looking at these two terms, what would the GCF be?
2.
2 what?
X to the third.
X to the third. So you do GCF of 2 and 8 is 2, and then you look at the x's, and you choose the smaller. So that's step 1. Find the GCF. Step 2. Write the GCF on the outside of a set of empty parentheses. Boom, there it is. Step 2, done. Step 3 is where the work is. If there's any, of any place. What this says is take the original terms and divide it by the GCF. Okay, and I'm going to go ahead. This plus sign. I'm going to include that plus sign into the division. Okay, so we keep track of our signs. Now, what does this look like now? Does this remind you of something we just did? How would we simplify that division? What you're really doing is you apply the quotient rule for exponents. What does the quotient rule say? When you got variable on top and bottom, you subtract the exponents. So that's what. So essentially, factoring is utilizing your quotient rule. So the 2's here cancel, and so do the x to the 3rd. But applying the quotient rule is x to the 3 minus 3, which is x to the 0, which is what?
1.
1. So this thing right here is really a 1. Keep track of the 1. What about over here? What about over here? We divide the 8 and the 2 to get what? Well, I'm sorry, positive 8 and positive 2 to get positive 4. Apply the quotient rule to the x's. X to the 5 minus 3, top exponent minus bottom exponent. And then that gives us what? 4x squared. That's what that means. Divide each term by the GCF just means divide them and take the power of quotient rule to simplify the resulting division. And so now take the quotients of 1 and 4x squared, whoops, and 4x squared there. Take those quotients and put them inside the empty parentheses, 1 and then plus 4x squared. And that is it. So I didn't really teach you anything new. What I did is I showed you 2 things you already knew, and we put them together. We'll do more of this.
So in the lesson, would it make us put X or would it make us put 1?
Where? Right here?
Yeah.
Let me ask you, what do you think?
I would assume 1, but X is 1.
No, x is not 1. See, this was x to the 0.
Oh, see, I didn't.
Meaning
Okay,
there are no X's,
never
but
mind.
there's always a 1 hanging back.
So if we take that bottom answer and we work it like a problem that we worked, we get the 2x3 plus the 8x5.
If you multiplied it, if you took that 2x to the third and multiplied it back in, you
Mm-hmm.
should get this original problem back.
I did.
Oh, you did that?
Uh-huh.
Okay, good. I'm glad that's good because that's applying the product rule to check your work. That's why we learn the rules of exponents. We're using the quotient rule to actually break things apart, but to check your answer, you apply the product rule to bring it all back together. So it all comes back together. Okay. So we're going to pick this up, and what I want to do now is I want to kind of look at a quick review with you, just to kind of get the juices flowing with order of operations again. But we're going to pick this up, and this is going to be the thing for factoring. There's a couple other things for factoring. It's not they're kind of cool. They're like more recipe pattern based, but this is the process when for factoring that we're going to really lean heavily upon. Okay, so let me switch over here. Okay. So let's do some of this. This is the skill review too, on that I mentioned that I posted, and I want y'all to do. Yeah, Adam makes a good point. Thank God for YouTube, and he's right. YouTube is a good resource. Check it out. Okay, so this skill review relies upon the order of operations. Please excuse my dear Aunt Sally. It's supposed to be a D. Sorry. Okay, so what's first? You tell me.
Parentheses.
We could, but we don't have to do the
Multiple.
parentheses in this step. What? Let me stop with the parentheses. Yes, we have parentheses for sure, and so that's a natural sort of starting point. Do we do anything in the parentheses? It's just a number, so we are done. We technically are already done with the parentheses. What you're looking for in the parentheses for the parentheses step, what that means is there's something to do, an operation, add, subtract, multiply, divide, something in there. But here in this case, we don't have that, so we can technically skip the parentheses step. So skip parentheses, whoops. What about exponents? No exponents. Multiply, divide.
Divide.
Which one first?
Well, there is a multiplication. Yeah, so multiply first.
Go
2
back to your,
times
go back to your other answer,
negative
Jana.
multiplication.
Remember with multiply, divide, look at it from, well, your angle, left to right.
Okay.
So which one do you hit first?
Divide.
Divide. So bring everything else down. And we do the division between 24 and 2, and that gives us
12.
a 12. So just be mindful of that left-right rule. Definitely going to appear. Okay, so now we have multiplication. So I'm going to bring down the 10 plus. And so what's the multiplying?
12 times negative 3. It'd be
So what?
negative 36.
Negative 36, right? I'm going to put it in parentheses just so I can, because I have a plus sign in front. I want to keep the plus and the minus separate. Okay, so multiplication's done, division is done, addition, subtraction.
Addition next.
What's this one going to be?
46.
Say it again.
46.
Close. Very close.
Negative 46.
Negative 46, right. Remember when you're adding the same sign, you add the numbers to get the 46, and then you attach the common sign. And that gives us negative 46. Questions on this one? All right, let's take a look at the next one then. Okay, so 8 to the second minus 2 to the third divided by negative 7 plus 5. What do we do? Where do we start?
The parentheses this time first.
Yes, perfect. So parentheses first will bring everything else down. 8 to the second, 2 to the third, divided by. So what's going to go in the parentheses?
Maybe 2? No, that's the
Say it again. I couldn't hear.
-2.
negative 2.
So negative 7 plus 5. When you add numbers of different signs, you subtract them and then attach the sign of the larger number. Because the 7 was the larger, we attach the negative. Okay. Parentheses, check. Done. Exponents. Do we have exponents?
Yes.
Yes. So what's the first exponent we're going to do?
8 to the second power.
Gives me
8 to the second power.
64.
64. Good. Then minus
6.
8.
8.
I could hear it in your voice.
8.
And then we just bring down the rest. Divided by 2. Divided by negative 2. Okay. What's next?
Divide
Divide what by what?
-8 by -2.
Gives us.
4.
4.
And go ahead and say,
Negative 4.
go ahead and say the sign too, because that's going to help you with your addition. Positive 4. Good. And then final answer.
68.
68. Exactly. Not so bad, huh? This is probably one of these two were probably the more challenging ones. And these here on the practice are what you would expect. Okay. So let's do this one. By the order of operations. Now remember, when you have a fraction, what do you do? Simplify the top down to a single number, simplify the bottom down to a single number. So how would I do that here?
It's absolute value.
So remember, order of operations. Do I have a parentheses?
Isn't the absolute value done? Acts as a parenthesis?
You treat it like a parentheses. That's exactly right. So we got to do what first?
-8.
-8 plus 24.
Gives me
16.
16. Perfect. Now what?
Exponents?
Before we move on,
We got to turn what's a positive already, so we just
do the absolute value now. So right, 16. So that becomes 5 minus
3.
3 squared. All right, now I'm done with the parentheses step. Exponents. Do I have exponents?
Yes.
So what does that give me?
9.
-4.
Right. So good. Good. You're on the next step too. So 3 squared becomes 9. Then we're simplifying our denominator down to a single number, And so 5 minus 9 becomes negative 4. Now what?
75. I mean,
Do you divide 16 by -4?
You get?
-4.
Yes,
4?
Zach, I can sort of hear you in the background. I think you got it.
-4.
Negative 4. Exactly right. Boom. There you go. But you got it. Absolute value you treat like a parentheses for the purposes of the steps, and then you just resolve it. Once you get it down to a single number inside, then just apply the absolute value. Good. How about this one here? So this one's I can type this one. So how would you go about doing this one?
The parentheses first?
Well, first thing we have to do is what? We have to plug it all in. See, here we are told what the values of x, y, and z are. So you want to go ahead and make the replacement. And I don't know why I can't. It's not letting me type, so I'm just going to go ahead and I'll type here. I see. So I'm going to make the replacement. So x is -9, minus is in front. Y is -4, so I'm going to put that in parentheses because I have a minus minus. And then z is 2. Okay? So the trick here was this part, was the y, because there's a minus in front of the y, but the y, that variable itself, is also negative. So now, treat it like a parentheses.
Yeah, the
-9, the minus minus becomes a +4. -9 plus 4 plus 2. What does that give me inside the absolute value?
-9. Wait, so how did we turn it into a 4?
Mhm.
How do we turn the 4 to a positive now? So -9.
So there's a minus in front of the -4.
Mm-hmm. So we just drop it into a plus, even though we didn't perform any action.
Well, that is the action. The minus minus cancels. It's technically multiplication.
Okay.
Remember, there's always a 1 in front.
Okay.
So it's -1 times -4.
Okay. So it's a plus.
Would it be -15?
Close. So -5 on the outside, absolute value. What's on the inside? Oh, close. I see what you're saying. So -9. So you do -9 plus +4. Remember, when you're adding numbers of different signs, you subtract them and use the sign of the larger number. So we subtract the 9 and the 4 to get 5, and then attach the negative. Do the same thing. -5 plus 2, you subtract the 5 and the 2, and then attach the sign of the larger value.
So -3.
And so this becomes what?
+15.
Close.
The -15.
-15. We have to do the absolute value first. The -3 is trapped in an absolute value. So you have to apply the absolute value of -3 to get what? +3. Then do the multiplication. And so we end up with a value, the final answer, of -15.
Okay.
Okay, so we are kind of right at the end here. So there's two more It's just combining like terms and applying the distributive property. And let me throw this one out to you all. How would you do this one?
You would do the B's first, 10B minus 16B, or you'd do, give me a second. You'd have to bring the 10 down, make it a positive, and do it to the same on the other side.
Let's pause there. I'm glad you said that, Jordan, and not to pick on you, but what you said, I know that someone else is thinking the exact same thing. When we do it to one side and do it to the other,
You combine.
what is the other side you're seeing? Is there another side?
The 16B.
There's no other side.
See, when we say, so this is a point of clarification. When we say do it to both sides, we're talking about what? The both sides of the equal sign. So here, if you notice, there's no equal sign. So that process doesn't apply.
You combine like terms.
Right, right. So what I want you to focus in on is take a look at the directions. Simplify. When it says simplify, you're combining like terms and probably applying the distributive property if you see parentheses. When you see the word solve, that's when you're going to do to both sides of the equal sign. So I want you to pair the direction with the process. And so similarly, before I go forward, if you noticed up in here, simplify. Simplify means order of operation. When you have all numbers, it's order of operations. Evaluate means, hey, plug the values into the expression and apply the order of operations. Simplify, when you've got letters in there, means combine like terms. And if you have parentheses, do those. So with that in mind, then, yes, we're combining like terms because we don't have an equal sign. The best we can do is just jam things together. So what we do, there's a myriad of ways of going about it, but what are the like terms, I guess, if you will?
You put negative 10B plus 16B.
Yeah. Let me do yours because I am. There we go. So negative 10B, good. You kept the sign in front of the B. Good. Then what?
4A minus A.
Positive 4A minus A.
Positive 4A, good. That positive tells us it's a plus sign. Minus A. And then what?
Plus 9.
Plus 9. Right. So when I combine like terms,
A negative 6.
close.
Positive 6B.
Because the 16 here is the higher number and has a plus sign in front. So right, it's this one is positive 6B. Then what? How do we combine the plus 4A minus A?
4 minus 1.
4 minus 1A gives us what?
3.
Negative 3.
So I didn't hear, but I heard someone say negative, but 4 minus 1 is 3.
Plus 9.
And then plus 9.
I don't know.
And so typically, by the way, not that it's always required, but we typically go in the order of the alphabet. We would write the A term first, then the B term. Then
I
the
was
9.
wondering why we didn't use the 8 first. That had me kind of confused.
You can't, both are equally correct. The preference, if there's a preference, it would be to arrange in alphabetical order. Okay, so the reason why I wanted to do all this was so that you wouldn't have that much work to do, because now all that's left is Just that one problem there. So you all take that problem, and we'll pick it up. Uh, we'll do it tomorrow, just to make sure you got it right. Any questions?
So this is on our assignment under 88.
88, yes. Let me make sure on
We
that.
just fill it in and turn it in, and that's going to be for a grade also.
Yeah.
Okay.
So can you
How
tell me
do
what
we
we're supposed to
fill
be
it in?
doing?
Say it again.
Can
We
you tell
can
me
fill
what
it
we're
in
supposed to be
online.
doing?
Wait, hold on. I think we got two. Let me do Allie first. I couldn't say
Me?
your question again, Allie.
Do we fill it in online or on paper?
You can type it on a Word doc. Type all this stuff. Type the answers, for the first part on the Word document, and then same thing here. Just type this on a Word document. Your solution. That's probably the easiest way. Or if you handwrite it and take a picture, that's fine by me too.
Okay.
Tiffany, I think you were the other.
Yes. Can you just tell me what we're supposed to be doing? Because I missed the beginning of the class.
Okay, yeah. So there's just a. Oh yeah, I'm gonna post the recording by the way too. I recorded it. So
Okay.
there's a skill set right here, skill review. This one right here. You should see it now. I think I made it visible. So that's what we were doing.
Not showing me. It's still on the slideshow.
Oh, thank you. There we go.
Okay.
So it's this one right here. It should be. So I uploaded it both as a PowerPoint and a PDF, just whatever
Okay.
you whatever works for you.
You want it emailed back to you?
No, this one you should be able to load it in. And even if the other one as well, go in and load it, like upload your document so that I have something there. So I see it's working now. So I see 6 students have been able to submit it. So take your document and upload it into the assignment. All right. Anybody else? As far as I see, by the way, y'all are doing very well on the first part of this material. So I know it's a little jittery at times to go into a test, but so far I don't have any concerns. Really, it's the nitpicky rules, like anything, signs, positive, negative, all that stuff. So, but that's normal. That's par for the course. I'm not going to test you on a sign with every problem. Occasionally, I'm going to throw a sign thing in there. So, you'll be on guard for it. Uh, but it's not going to be, I'm not going to try to trick you. I'm not going to try to do that every time. That's just laborious and I'm not into that. Not laborious, but my point is it just feels like not everything's going to feel like a trick question. So I do want to see, I want to know you had the skills. So I don't need to always do a sign thing to do that. Okay, yeah, Jackie, what you got?
What day is the test? Is it tomorrow?
Wednesday.
Okay, but you're uploading it tomorrow so that and we'll be able
I'm
to
doing it tonight, so you should see it by tomorrow.
Okay. And then it's on Wednesday. And we're taking it during our regular class hour?
No, you can take it any day on Wednesday that you
Anytime on
want.
Wednesday?
Yeah, I mean, once I load it too, you can do it on Tuesday if you want. So
Okay.
it's kind of it's really your choice.
But it's a
So
one-shot thing. You can't retake the test. So
let me look into that. I probably will get if I can. I'll give you 2 attempts. Uh,
okay.
I think that's let's say it this way. I was never a good test taker. uh, in law school, I was I did poorly on my first semester exams. So I always love a redo where I can. I was very nervous. So yes, if I can give you the redo, I will. It's more time, if you want to redo it, but it's there if you want it. So
Okay.
If we are going to use our notes, how are we going to use our notes if they're on the computer?
that is up to you. I don't think you're going to need your notes.
Is it on the lockdown browser or is it on?
Uh, I don't know.
Because I just took a test last night on my Jazz and it wasn't It just made it so that we couldn't like go back, but we could still look at our notes.
You can look at your notes for sure.
Okay.
Yeah,
Okay, that's what I was
I
wondering.
don't object to that at all.
See if it is on lockdown browser. So in the beginning, I had no issues with it, but apparently, if you have a Chromebook, lockdown browser has issues with
So I'm
Chromebook.
probably not going to do lockdown browser because of that, because I know Chromebook is problematic. So don't. I'm not going to do lockdown browser. I'll just tell you that right now.
Okay,
Because
so
of
we
that. So,
can look at our notes. That's on our
oh yeah,
computer.
yeah, definitely.
And I
But
have one more question.
hmm
For Wednesday, do we still attend our regular class period on WebEx?
no, we're not going to be in here. So
Okay.
you do your test when you can do it during the class period, but just do whenever you want that day.
Okay.
So if there's a
Thank you.
better time.
So don't log in Wednesday.
No, you're going to be doing the test. So
It's a long test.
Are you still going to be accounting us for Wednesday though?
yeah, I'll say your submission of the test will be your attendance. But no, I will not be on here either, by the way, because I imagine, I mean, I can't answer questions. So and it's too distracting because if I keep talking, then everyone's gonna pick their head up and like, oh what? It's too distracting. So I don't want to do that to you all. So no, don't come. Focus on your test. Quiet place, and any time of the day. If it's better for you to do it at 9 a.m., great. Better for you to do it at 11 p.m., even better. There's no rule that you have to do it here. I'm not requiring that. All right.
Will we be able to put the answers on the test, or we'll have to do the upload like we're doing these
No,
lessons?
this will be this. I'm going to do it for in Hawks, so it'll automatically grade, and you'll get your grade right then.
Okay. And is it graded just like the lessons? 80 and above is 100, 79 and below
No,
is
this will be
80?
straight up. Whatever you get, you get.
Okay.
Whatever it is. So you get your points if it's not up to the mastery level, but
Yeah.
you get your points whatever they are.
Okay.
And I'm thinking of probably 10 questions. I mean, I'm not going to think. It's not going to take you an hour, is we're probably thinking, but an hour to an hour and 15. Okay, that's about right. And this is the complexity of what I picked these problems on purpose. I want you to see what I'm looking at as something you should be able to do. Anybody else? All right. Well, I'm going to get this processed, and I'll load the 2 videos from the last 2 lectures up into YouTube and send that your way. All righty?
Okay.
Okay. If you upload it tonight and tomorrow, can we just do it tomorrow too?
If I upload it tonight, say it again.
Can we just do it tonight, tomorrow, whenever you upload it?
I was a failure.
I don't know. You can hear
Are you
me
talking
speak.
about the test?
Yeah.
Yeah, I'm working on it tonight. Yeah, so if you
Oh, okay.
once it's
I get
ready,
you.
yeah, you can do it tomorrow. I'm fine with that too.
Okay, that's all I was wondering.
Okay. All right. Hope you have a good night. Gina,
Happy day.
congratulations to your daughter, by the way. That's awesome.
See you later.
Have a good one.
All right.